In this video, we're going to continue topic 10.8, and we're going to look at example C. So in this example, we're going to go ahead and substitute in n plus 1 anytime we see an n. So this is the limit as n approaches infinity of n plus 1 to the n plus 1 over n plus 1 factorial, and then we multiply by the reciprocal of the original. All right, and absolute values around it. Then we're going to try to simplify this. So let's see, I'm going to rewrite some things. I know that n plus 1 to the n plus 1 would be n plus 1 to the n times n plus 1 to the first. N plus 1 factorial is n plus 1, and if I go one beyond, it would be n factorial times n factorial over n to the n. All right, and then I'm going to look at doing some canceling here. So it looks like my n factorials cancel. N plus 1 cancels, so I am left with the limit as n approaches infinity of n plus 1 to the n over n to the n, which I could rewrite as n plus 1 over n all to the n power. Now, this isn't something you would probably know unless I told it to you. So if we look at that, so I'm going to graph that. So look at this is what it's like graphed. So when I graph it, notice that it does have a limit, and that limit is the value of e. So what that function is, this is actually the definition of e. So this is equal to e, which is greater than 1. So when I am greater than 1, we know that it diverges. So we would say that therefore it diverges by the ratio test.